Greetings. So we're going to go over the Tier 4 system. I'm using our 4045 that's in the shop. And I'll be using the board. We're going to start with our air intake system. This has a 2-stage filter. It's got one that holds back bigger particulates, and then one that'll filter out the smaller fine particulates. From there we go to a turbo. This one, I believe, is a wastegate turbo. Really hard to see these turbos and exactly what they're doing, but there's 2 turbos in series. One's a wastegate turbo. The other one might be fixed or a VGT. It's really hard to tell. From there, we go into, after the turbos, the fresh air is going to go through the charged air cooler, or air-to-air aftercooler. That's on this side of the radiator. So the radiator and the charged air cooler are bolted together. Both of these have air blowing across them from the fan, and that will cool both the air that's going through here from the turbos and the coolant that flows through the engine. So then that cooled air is going to go into the cylinder. It's going to get used up, and we're going to have waste air. Some of the waste air is routed up to here and goes through both your turbos to spin them up. A portion of that air is going to get routed through your EGR cooler. EGR cooler has a water jacket that cools off the exhaust gases that are flowing through it. The exhaust gases that are being rerouted back into the engine is to cool the cylinder off with inert air. So the engine's not using as much fresh air, producing less power and less heat. The engine controls how much of that exhaust air is getting rerouted back to the intake through the EGR valve. It's really hard to see on here. We'll look at it better on the display. After that air gets rerouted back through, eventually some of it's going to make it back out through the turbos. And we're going to start going through the exhaust system now. Here is a temperature probe. It's got a skinny neck. There's 3 of them on this particular engine. Then we're going through the DOC, the diesel oxidation catalyst. This transforms NOx into NO2 to be broken down later on in the system by the DEF. Here's another temperature probe. I don't know if you can see it. It's over here. It's got a skinny neck. Come on, phone, focus. It's got a skinny neck back there. The next thing we hit is part of the differential pressure sensor. These 2 blue lines are on either side of the DPF, the diesel particulate filter. So these 2 lines are sensing the difference in pressure to see how clogged up the DPF is. What the DPF does is it collects the soot from our exhaust. So this is the differential pressure sensor. Both these air lines are coming up to it, and it's sensing the difference in pressure to know if it needs to go into a regen. The DPF here, you can see these V-band clamps. This is replaceable and cleanable. There's a gasket material in here, so when you're replacing it, be sure that you're removing that gasket material. So I'm going to go to the other side of the engine now and try and not make people sick. And then the next sensor we hit is the NOx sensor. It's a thick sensor. It's got 2 stages in here. We'll go more into how it works with a video. But it senses how much NOx is in the exhaust stream. NOx. All right. This is the decomp tube. It's from this V-band to this V-band. Inside is something called a mixer. And what that is a series of baffles to help swirl the air with the incoming DEF system. So now we're going to cover the DEF system and we'll join back up there. So we've got the DEF tank. What the DEF tank does, the diesel exhaust fluid tank, it holds diesel exhaust fluid. On top of the DEF tank, we have the DEF tank header. That's this whole piece here. This will sense the level. It could have a quality sensor in it. And it has coolant lines running through it to warm up the DEF. DEF freezes at 32 degrees Fahrenheit, and some of these vehicles are working inside, ranges where it'll hit below 32 degrees Fahrenheit. So these are the coolant lines. They're the big thick lines. These little lines are what's carrying the DEF. The DEF tank header has a lift pump, kind of like the fuel system. It's got a lift pump in it, and it pumps it up to the dosing unit. The dosing unit has a filter, and it kind of acts like the injection pump, where this is pushing diesel exhaust fluid up to your DEF nozzle. This DEF nozzle has coolant lines. That's the blue ones are coolant to cool off the DEF nozzle, because it's in the exhaust stream, it's going to heat up. This is the actual DEF line. When you shut down the engine, the DEF system, using the dosing unit and the DEF tank header, are going to purge the lines all back to tank so that it doesn't freeze up in the line when the vehicle's off and below 32 degrees. So the DEF injector is going to, just like a diesel injector, it's going to mist out DEF on command from the ECM. So all this is going to get mixed up in here, the DEF and the exhaust stream. It's going to start changing into water vapor and nitrogen gas, but most of that happens in here. You've got two filters here, they're put together. You've got the AOC, the ammonia oxidation catalyst, and the SCR, the selective catalytic reduction. So we're going to hit the SCR first, the selective catalytic reduction, and that's where most of your with that precious metal it's got in it, it's going to act as a catalyst, and that's where most of your exhaust is going to transform from nitrogen NO2 into nitrogen gas, and we're going to get water vapor. In the AOC, the ammonia oxidation catalyst, it's going to act as a sponge and collect any unused ammonia from the DEF fluid. And I forgot to mention, here we have another temp sensor before the SCR. And then on the other side over here, I don't know if I can get to it, there we are. That's a NOx sensor. So when it comes out the AOC, the ECM is seeing how much NOx is coming out of the exhaust stream to make sure it's doing its job effectively. So let's go over to the board now and look at some of these components outside of the engine. Here are your three temp sensors. They're just long, skinny probes. Here's your NOx sensor. It's just like an O2 sensor for a car. This is your high pressure fuel pump. This is the DEF tank header. This is the dosing unit. And right here is the cap for the filter. If I had the tool, I could actually take this off and show you the DEF filter, but I can't. All right, and then we're gonna come around. Here is your DEF nozzle, and let's see, can we see in there? I don't know if you can see in there or not. That's the actual nozzle. All right. What else are we missing? Here's the differential pressure sensor. These are actually the fuel nozzles, and there is some kind of sensor that could be either oil pressure or NOx or something. Okay, so butterfly valves. These are what we use to control how much air is going through something. So there's one of these on the end of the turbo, and that controls how much exhaust is going out. And then this is the one that's on the EGR system, the exhaust gas recirculation system. I think I forgot to mention that. So this is the EGR valve. That's your common rail, your high pressure common rail. I'm trying to see anything we're worried about with the Tier 4 system. I think that's pretty much it. So if you have any questions, please shoot me an email or see me in lab or in class, and we can answer your questions. All right. I hope you have a great day. Thank you. Bye.